Hello everyone, welcome back to my channel. I hope you guys are doing amazing. So in today's daily challenge on Leetcode, we will learn some amazing techniques to solve some general permutations problems. We will see how to generate permutations using BFS if you do not know it already. And to solve this problem, we will see two approaches starting from 26 to the power L into N, and we will factorize it all. I will improve it all the way till L factorial into L. So this NL will be nothing but the length of the subsequence, which is given to be less than 8. Uh, it's strictly less than 8. So we will see how all these time complexities are coming, and in detail we will see everything. So definitely stay till the end of the video. So let's try to move on to the question. The longest subsequence repeated k times. You are given a string s of length n and an integer k. Your task is to find the longest subsequence which is repeated k times. A subsequence is a string that can be derived. The subsequence you already know, I guess, what is the meaning of a subsequence. And you need to find a longest subsequence which is repeated k times. So return the size of the longest subsequence. If multiple such subsequences are found, return the lexicographically largest one. Okay. If there is no such subsequence, return an empty string. Okay. So I guess you already know how it is working. So if you try to understand this, let's lead code. The answer is k equal to 2. For k equals to 2, the answer will be 3. So let's try to understand how this is working. So if you see, let's lead code. If I write, let's lead code for k equals to 2, you need to generate two subsequences. Okay. So you see, you can tell that LET, this is a subsequence which is LET, and again this L, this E maybe, and this T, this is another subsequence. So this is repeated two times. This subsequence is repeated two times, and it is of length 3. So we output 3. Now you might ask that why is this not LETE? So if you see LET and you want to take E from here, and from LETE, if you want to take E from here, that is not allowed actually, because this subsequence, it is also told that this subsequence must end before the starting of this subsequence. So you see, this subsequence has ended here, and then this L comes. Okay, so now if you try to take LETE also, what is happening there? If you try to take LETE also, you take this and this, and your subsequence, first subsequence has ended here, and from here you do not find anything such as let, because L has already gone back. Okay, L has already gone back. So the thing is there that you do not consider let, you only consider this length 3 let for solving this. Okay, so I guess that was sufficient for the intuition. So you see, we will try to think what can be the brute force solution for this. First of all, what can be the very brute force solution without optimizing anything? What you can do. So first thing which you should note here is that n is less than k into 8. Whenever something is given, you see n is less than k into 8. Okay, and n by k is nothing but less than 8. So it can be at max 7. It can be at max 7. Okay, it can be at max 7. And this NYK is what? It is nothing but the length of the subsequence, right? This K you are repeating K times. This L you are repeating K times to get the whole N, right? So at max, this is value of the max length of subsequence, max possible length of subsequence. Okay, so that is a maximum possible. So if I am thinking of something which is very brute force, what you can do is that you can generate all possible subsequences. So it can be of 7 maximum, right? L can be maximum 7 because it is less than 8. So you generate all possible subsequences, A to Z, A to Z, A to Z, 26 possibilities. You just keep multiplying 26 possibilities L times. Okay, so you see, if you generate all possible subsequences, so let's say you generated something like A, B, C, B. Okay. Now, you just check for all possible subsequences. You just check if it can be repeated k times and a subsequence is present. Then you just store your answer as the, and if it is of maximum length, then you store it as your answer, that it is my I mean, it is my best subsequence. Okay, it is my best subsequence. If it is of maximum length, then you just take whichever is the maximum length. You just maximize it. Okay. So how you will check whether, let's say, k equal to 3? So you just repeat it 3 times: a b c b, a b c b, a b c b. You just repeat it 3 times and check whether this repeated string is a subsequence of s or not. If this is a subsequence of s, then definitely this can be repeated k times and made a subsequence of s. Okay. And this is my possible answer. This is my possible answer. So out of all my permutations, if this is the maximum value, maximum length, I will take it. I will take it. Okay. So what is the time complexity of this? If you try to see it, it will be 26 to the power L. And every time you are checking this in O of n, whether it is a subsequence or not, 26 to the power L into n. Okay. So how will you generate permutation? So the main question is that if you already know this concept, then it is very simple for you. The question is that this is a concept, in fact, how to generate permutations. Okay, how to generate permutations uh, of a string, how to generate permutations using BFS. Using BFS. Okay. So this is a common strategy. If you already know this, then this problem is very simple for you. But if you don't know this, just stay with me. I am just explaining you. So let's say you want to generate a non-repeating permutation of A, B, and C. So you already know that this is 3 factorial or this is 6. Okay. And if it is repeated, it will be 3 to the power 3, which is 27. Both of this can be generated using BFS. So what you can do, what you do in a BFS, normal BFS, you keep a queue, right? You keep a queue. In this, you initialize the queue with an empty string. Okay. Now, this empty string, you append it with all the possible choices. You append with A, you get an A string. You append with B, you get a B. You append with C, you get a C. Okay. Now, this A you append with, this is, now these are all the elements of the queue. You are doing queue dot push. You are doing queue dot push all the choices. Okay. You're just appending and pushing all the choices. So these are all the elements of a queue. Now you start a BFS from A also. You go through B and C. You go to B and C. If you append, so if you try to append B here and you try to append C here, what do you get? You get AB and AC. Okay, you get this. Now, if you try to append B here, for B, if you try to append A and C, you get nothing but BA and BC. Similarly, for C, you can get CA and CB. Okay, okay, so you get this. You get this. Now, what is the only thing which is left here? C. So you get ABC. Which is left is ACB. B is only left here, and BAC. Okay. So whichever is left, you are just appending it, and the element. These are also the elements of the queue. Okay. So CAB and ABC. So you see, you get all the permutation. Not okay. So this will be CBA. Okay. This thing will be nothing but CBA. So I did some mistake here. This will be C you append with B and then you get A. Okay. So you get 3 factorial, total 6 combinations. Okay. You can generate using BFS, you can generate permutations in this way. And if you want to generate 3 to the power 3, that is also very simple. That is also very simple and easy. I will just tell you once how you can generate it. It's nothing new. It's nothing new. It's the same thing. You start with an empty string. You can append. It is rather an easy one. A, B, C. Okay. Then again, you just append A, B, or C. You get A, B, A, C. Similarly, you get 3 choices here. Similarly, you get again 3 choices here. Then again, you append it using AA, AAB, AAC, okay, AAA. So you get again, you are appending A, B, or C. You see, you are getting 3 choices for 1, 2, 3. This is 6, this is 9. So for 9 combinations, you are getting 3 choices. So you got 27. So in this way, with or without repetitions, using BFS, you can generate permutations. Okay. So now, if you try to solve this problem, it becomes very easy actually. This brute force way, it becomes very easy. So you are thinking that this should not pass actually. 26 to the power L into N should not pass. But it is the fault of Leetcode. I will say it is the fault of Leetcode that it is somehow passing. this method is somehow passing. Okay, so we can also generate, so if instead of this 26 to the power L, we can also do L factorial into N, as I showed you using the BFS method. Okay, so both of them I will see how will I convert this 26 to the power N to N factorial, and how will we do some more a little bit of optimizations here and there. We will all see it. Okay, so let's try to code the solution. Let's try to code the solution, and we will see how our approach goes hand in hand. Okay, so first of all, I will try to keep very simple. Okay, I will try to keep things very simple. So I will do n equals to int n equals to s dot size. Okay, this is not required for now, but now I will keep a queue. Okay, what will that queue contain? It will contain string. Okay, as I told you, I will push an empty element in the string. I have pushed an empty element in the string. Okay, now I will choose string answer. Okay, which is my best string, which is also of the maximum length, right? So as I do in BFS, while queue is not empty, I will just go on through the BFS, and string str, I will take a string str where I will put this queue dot front. I extract the front element of the queue, and what I do is dot queue dot pop. Okay, it's very simple, very easy. Okay, till now it's quite okay. So what we do? What we do now? We store it the answer, right? So what I do is that I will take a care. I will see from A to Z which one I can append. I am writing the brute force approach first. Okay, so from A to Z, from A to Z, which string I can append. Okay, so how to tell that exactly? So you see, I am creating a string temp, which is nothing but string str plus c. I am appending a character c to the temp str, and now I check that if exists something like if exists. What does this mean? This checks whether this temp is repeated k times in S or not. If it is repeated k times, it means that this is our possible answer. This is one of our possible answer, and we will do q dot push temp. Okay, we will do q dot push temp, and in the answer also, this since this is our possible answer, I will try to append it try to append with more elements. This I am doing means try to append with more elements. Okay, and what I am doing, I should also update my answer, right? So if this temp dot size is becoming greater than my answer dot size, okay, if it's becoming greater than my answer dot size, what I will do? I will do answer equals to this 10. Okay, I update my answer to the best possible value. Now you see here as also it is told that return the lexicographically largest one. Return the lexicographically largest one. So what you can do, or what if they're equal? They will not be stored, right? So if they are equal, and this answer, this temp is lexicographically larger than, so you can compare two strings using just comparison operator in C++ if you don't know. And this will return if temp is lexicographically larger than the answer. In case of equality, then still you store this temp in the answer. Okay, so that's what we need to do here. Okay, and at the end we just return answer. We just do a simple thing, that is returning the answer. So that's all. Not that's all. So we need to write this if exists function, right? So if we want to check that if exists, it means that you have a string s, you have a string s, you have another string p, let's say p, and it's repeated k times. It's repeated k times. So you want to check whether the string which is repeated k times exists in s or not. Okay, so while k minus minus, what I do, I just append this str plus equals to p. Okay, so this is very simple. I just append this k times k, just p. I just append it, and I will keep another variable j. You can do it using pointer also. It's no problem. But I will try to keep things very simple and very easy. So I will just go through the main string, I will just go through the main string to check for subsequence. So if how to check for subsequence, if this s of I is equals to str of j. Okay, I guess you know already how to check a subsequence. Then just do j plus plus, and if you see anywhere that j equals to str dot size, it means that you have already got your answer. You just break it. You have already got the subsequence, and return if j equals to str dot size. Okay, so if the j is a valid subsequence, it means that uh, this will be at the length n. So if you did not understand what did I do in this subsequence, so let me explain you this also, although this is very simple. uh, let's say you have a subsequence, you want to check a subsequence, let n l s q e x t. Okay, you want to check for the subsequence let in this. Okay, so what you do, you go through all the value in this I pointer, and you keep a j pointer to 0, which points to l at first. Okay, you see this string of s of I equal to this str of j. So you increment this j pointer, and you keep incrementing I every time. You just keep incrementing I every time. Then again you get an e, you compare it with j and again increase it. Then again you just keep incrementing. If you get a t, you just again increase it, and at the end j will be equal to the length. J will be equal to 3 right here. Okay, because that's the length of this let. Okay, so that's what I did here. If j is length of the let, you just check it. So it's very simple. Just you need to check a permutation. So now this is a brute force solution which should not pass, but I have checked. Leetcode does not have such strong test cases. Okay, it will pass. If you try to submit it, it will just pass. So you can understand how weak the Leetcode system of solution checking is, because I have seen it many times. Also, the brute force even passes. So you see, it should not pass because it is. You can see it is 26 to the power l, right? 26 to the power 7. That is a very big number. 26 to the power 7 into n, which is 1000. Still, it is passing. I mean, I don't know why, but if you try to optimize it, how will you optimize it? Okay, so some changes which we can do is that instead of I was doing to find the lexicographically larger one. Okay, so what you can do instead, you can do this. You can do this. You check from the back. So automatically the first thing which will come will be the lexicographically larger one, and subsequent things we do not need to check. So you see, this also works. This also completely works. Okay, I am just reducing one comparison, so a little bit of time complexity. So what we need to do, you see now. Okay, how we can optimize it? How we can optimize it to something which is more optimal? So you see, let's take that let's Leetcode criteria only. I am uselessly taking all the elements. Okay, what I am doing is that I am uselessly taking all the elements from A to Z. I am appending it. But why should I do that? You check for this case. Let's Leetcode. Okay, you will see something. You will see some pattern. Here L is present 2 times. If I'm creating a map, L is present 2 times. E is present how many times? 4 times. Okay. T is present 2 times. S is present 1 time. O is present 1 time. D is present 1 time. Okay. And some things. Okay. I think that's all. That's all. So you get 8, 11. So I think you have some other thing also. So C is present 1 time. So you see, within these criterias only, our answer will be. Why I need to search in A to Z? That's I'm just wasting my time doing that. Okay. So I do not need to search from A to Z, first thing. Second thing is that out of all these, which are my possible things which can be in the subsequence? So do I need to traverse through all of these letters actually? So I think we do not need. Why? Because you see k is here 2, and the total length, if you check, n is 12. So maximum length of the subsequence is nothing but n by k, which is 6. If you are repeating k times, if you are repeating subsequence k times, so n, so that subsequence length l into k can maximum be n. So that l max into k can maximum be n. So l max is nothing but n by k, which I told you, which is 6. Okay, I think you understand this. I think you easily understand this. Do not need to. I do not need to do so much. So you just know this, that this is L max. Okay, this is L max. This is the maximum length of the subsequence. So also each character needs to be, whichever character is present here. Let's say character X is present here. X needs to be present here also. So you are finding this subsequence k times. Okay, you are finding an L length subsequence k times. If a character C is present here, it must be present here, it must be present here, it must be present here. Since it is repeated, right? So C must be present k times. So I will need to check only those things which are present k times. You do understand this, right? I will need to check only those which are present greater than or equal to k times. Okay, and what is the maximum values that I can take? What is the maximum values that I can take in a single subsequence? In a single subsequence, if you see, I can take divided by k. If you see, in one subsequence, if total number of subsequences k is 2, in one subsequence L can be present one time, in one subsequence E can be present two times, in one subsequent T can be present at max one time. Okay, so these are only the cases which you need to take for a single subsequence. This LET, this occurrence of L can be, if you do it two times for a single subsequence, it is 2 by k, which is 2. Again, this is also n by k. So this is again becoming this frequency value by k. Okay, this is 4 by 2. That's why it's 2. Okay, so you understand that you got two facts here. Let's try to fact check things now, what we have understood. Okay, take strings. Fact number 1, take characters which have frequencies value greater than or equal to k. Okay, frequency by k. Okay, frequency by k is the, I guess you understood why I'm doing frequency by k. Okay, because that's k times, so each subsequence is the maximum possible times a single character can be present. A single character can be present in a single subsequence. Okay, a single character can be present in a subsequence. Okay, in a single subsequence. I get you understand this easily also, that maximum this frequency by time. Okay, so what you need to do is very straightforward for the optimization. What you do here, you just create a frequency array. You just go to something like this, frequency 26. Okay, and you go through this auto, let's say C from S. You just do frequency of this C minus A. Okay, C minus A plus plus. Okay, so C plus A. Okay, minus A, because it is a character, so you just subtract this A. Okay, so you store all the frequencies. Now you have all the frequencies with you. Now what you need to do next? Okay, do something. You reset the frequency. Do something with the frequency map. Okay, do something with the frequency map. If frequency of I is less than k, I do not need at all. So I will just reset my frequency. I do not need at all. I'm just pushing as much as possible. Else, if it is, how many times do I need? I need divided by k. Frequency of I divide equal to k. You understood this, right? I think you understood this easily, because that's what I just now told you here. At maximum value, maximum length, frequency by k can be possible. So I just do that. Okay. You understood how to do the frequency portions, and here I will do a simple check. I will do a very simple check. I will go through frequencies this time. I will go through int I equals to, let's say, starting from 25, I greater than equals to 0, I minus minus, and this char C, I have nothing but I plus A. I'm checking in this manner. And if this frequency of I is something less than or equal to if it is equal to 0, you just check. If it is equal to 0, you just continue. Do not need to do anything with the loop. Do not need to do anything with the loop. You can just continue with your stuff. So you just check this. If you try to run this, still it is not very optimal. I will show you more optimal. Okay. You can just stay with me. You just realize that this is somewhat very optimal than the previous one also. But we can make it more optimal. How? Try to think how till the time it gets submitted and shows how much bits it is. You see, you have 55% bits. Okay. So now can you do it to something which is more optimal? Are you ensuring any factorial thing here? You are not ensuring really, right? You are not really ensuring. So how can you do that? You tell that, what did I tell you? Using the BFS, when I was explaining you the BFS, how to generate the factorial. If I go to that, how you generate the factorial? You make sure which are already present in the string that is not present. Okay, A is already present in the string A. So you just append B and C. You see that A and B is already present, so you just append C. So you just apply this. I mean, very easily you just apply this. You create a vector, let's say n frequency, okay, and every time you new frequency, you just update it to the old frequency, okay. You just update it to the old frequency, and for auto, you just do what? For auto X, you go through the character X in str, okay, things which is already present. This is the thing which is already present, right? You go to the str, okay. uh, you do frequency n frequency, new frequency, you just update them. You just update X. You are just decreasing the frequency here. I think you easily understood this, right? You are just decreasing, which is A, okay. So if you have the A, you decrease the frequency of A. So initially what happens here is that you A frequency is 1, B is 1, C is 1. You see that A is there, so you just do A minus minus, you just make it 0. Okay, that's what I'm doing. For all the strings which have the some frequencies, you just decrease that frequency, and instead of this n frequency, you check this n frequency every time. So this way you're ensuring that you are not repeating the previous value. You are not repeating the previous value, and hence the time complexity will be L factorial into n. Okay, and L is 7 times, so 7 factorial into 1000. This completely passes, and within the bounds. This is within the bounds also. Okay, so if you try to submit this, you see that you have something error. So let's try to see what kind of errors are we having. So you see, I did not do this. Okay, I need to do this, right? Because this is a character, and I am in n frequency. The indexes are 0 from 0 to 26. If you try to submit this, you will get something. You should get something better than 50% at least bits. Okay, you should get something better. So you see, you get 72%. Okay, so this is the complete optimal one, I will say, as much as I could do. This completely ensures that you have n factorial, the final time complexity to be something like O of L factorial into n. Okay, this L is nothing but 7. Okay, L is nothing but 7. So L factorial is nothing but 128. You know it, right? 128. So into n is 1000. So that definitely passes within the bounds. So it's very simple and very easy. I guess you, or if you knew this method of generating permutations of string, I think this would be a simple problem for you. But if you did not know, this would be a hard problem. So if you learned something new and interesting from this video, definitely write in the comments. Okay, so that's all for this problem. It was a hard mark problem for Leetcode daily challenge today, but I hope your day is going to be really easy. Thank you so much.